This lesson is going to be about determining domain and range given a graph. The first graph we're going to look at is a parabola. To determine the domain of any function, you look at the farthest left and the farthest right points. So in this one, the farthest left is going to go through that arrow. The farthest right is also going to go through that arrow. Those arrows indicate that the function is traveling up and left on this side, and it's traveling up and right on this side. So it's going from negative infinity to positive infinity. Then if we look at the domain, or excuse me, the range of the graph, the range is going from the bottom point, this one right here, to the top point, and again it's going to run into those arrows. So it's going from -4 to positive infinity. Let's take a look on the next slide of how that would look. As you can see, I've written my domain as a compound inequality, which is this right here. Negative infinity is less than x, which is less than infinity. Or you can also just write this script r, which means all real numbers. The range then goes from -5, that's that point right there, all the way up to positive infinity. And notice there's no line underneath infinity because you can never get to infinity. And that's what that line means. It means it can equal that number. Let's take a look at this graph. Notice that this graph has a relative maximum point here and a relative minimum point here, but those don't matter. We're just looking at the lowest point, which is an arrow, the highest point, which is an arrow, the farthest left arrow, farthest right arrow. That means it's going to go forever, both in the left direction and the bottom direction, and up and down. So the domain and range are both going to be all real numbers. Notice again, I put the answer in the form of a compound inequality or with the script r. Same thing for the range with the y values, a compound inequality or script r. No lines underneath the inequality signs. Here we have a piecewise function, but again, it doesn't matter if the graph is split up. We're still looking for the farthest left and the farthest right point. In this case, the farthest left is going to be at -6, and the farthest right point is going to be at +9. The lowest point is going to be at -8, and the highest point is going to be at +8. The numbers in between don't make any difference. Here's what the inequalities would look like. Notice that it goes from -6 to +9, both arrows pointing to the left with lines underneath because it's a solid dot at both locations. The range does not have a line underneath the bottommost part because it has an open circle there, but it does have a line underneath at the 8 because it goes all the way up to a +8 and it has a solid dot. Now you try finding the domain and range on your own for this graph. Remember, you're going from the farthest left to the farthest right for domain, and then from the bottom to the top for range. Be sure to hit pause if you need more time. Did you get it right? The range is a little bit tricky for this one. You have to put the negative infinity first. You cannot switch these. So be careful. Negative infinity is my lowest number. 4, this point right here, is the highest number. Now try this one. It's just a straight line, kind of boring, but it still has a domain and range. Can you find it? Nice job. Both the domain and range are all real numbers. I can put in any x values and any y values, and it will be valid for this line. This graph should look familiar. Remember before we had the radical function where it was starting at a number and swooping down. Now we're starting at a number and going up. So can you determine the domain and range for this one? Did you get them both right? Hopefully you remembered to put the line underneath by the 0 and the 3 and no underlining by the infinity symbol. Here we have a circle which, although it is not a function, it still has a domain and range. And remember, it's not a function because it does not pass the vertical line test, which means if I draw a line through it, I would hit it at more than one point in several locations along the graph. Find the domain and range. Did you get it right? Remember, we go from the leftmost point to the right point, the farthest bottom to the farthest top. Again, we have a line underneath all of these because the graph goes through those points. This is another piecewise function, but it doesn't matter. You're looking at only the furthest left, furthest right, lowest, and highest. Hopefully you're a pro by now. Let's see if you can do one more. Here's another graph with an open circle on one end. Hopefully you will remember what to do. Did you remember to not put a line under these two and then to add a line under these two? Remember, an open circle means it can get really, really close, but it can't touch it. Great job, everybody. You are well on your way to being a real mathematician.